Okay, let's take a look at a hypothesis test for a population mean. Some requirements. Samples obtained using simple random sampling or from a randomized experiment. Sample has no outliers, and the population from which the sample is drawn is normally distributed, or the sample size n is large. N is greater than or equal to 30. Sampled values are independent of each other. Now, we're going to assume that all of those are true for the examples we're going to look at. I've made these up, so but we'll assume it's true. Let's take a look at the p-value approach using the TI-83-84. First step is write down a shortened version of the claim. Step 2, come up with a null and alternate hypothesis. H0 always has the equal part on it. Step 3, see if claim matches H0 or H1. Step 4, find the p-value using a t-test. And if p-value is less than alpha, reject H0. If p-value is greater than alpha, accept H0. And determine the claim based on step 3. Okay, note, practical significance refers to the idea while small differences between the statistic and parameter stated in the null hypothesis are statistically significant, the difference may not be large enough to cause concern or be considered important. What does this mean? Well, I did a test one time, a claim, based upon some data from the college, and it was about DWF rates. And while it showed it was statistically significant, the actual number of students that were involved in a change from this percent to this percent really didn't make much difference. So that's what it's referring to. Use some common sense along with the statistics, basically. Okay. The mean amount of fluid in a bottle of lens cleaner is 59 milliliters. Well, they're telling us mu is 59. And now it says mean, so that's why I know it's mu, and it doesn't refer to a sample size. A researcher believes that the mean is actually lower than that, so that sounds like our claim. So lower than 59. Okay. 15 bottles are sampled, so that's our N. The mean is found to be 58. So X bar is 58. It's X bar because it's referring to the sample, that 15, with a standard deviation of 1.2. So S will be 1.2. Again, it's a sample, standard deviation, because it's referring to the sample. Test claim based on this information that alpha is equal to 5%. Okay, so let's go through our steps. Step 1. Write down a shortened version of the claim. Well, we got that. Keep in mind lower than is less than. Now these are mu's, because we're talking about population mean. Step 2, come up with a null and alternate hypothesis. H0 always has the equal part on it. Well, this will be less than, and this will be greater than or equal to 59. The only symbols you can put on H1 are less than, greater than, and not equal to. The only symbols you can put on H0 are less than or equal to, greater than or equal to, or equal to. So when this one is a less than here, I knew it had to go down on H1, because these are the only symbols that we put there. Now, the book will always have an equals on H0, for at least this current textbook. Things change. Used to be our old textbook had this format, and I like this one better, because these are opposites of each other. So if you got less than here and you reject this, well, opposite of this would not be equal. It'd be greater than or equal to. So it makes more sense to me, I think, when there are exact opposites. Gives you the same answer, so it really doesn't matter in that regard. Step 3, see if claim matches H0 or H1. Well, this is a less than, so it matches our H1. Find your p-value using the t-test. Okay. So I'm going to press stat, right arrow over to test, and down arrow to t-test. Now, data is when you're given raw data, and stats is when you're given summary statistics. We have summary statistics here. So I'm going to right arrow to stats and press enter on it. And then I'll down arrow. Mu naught, this is the number off of your claim. Well, that'd be 59. So it's off your claim, H naught or H1. Now X bar, well, we said that was 58. So put in 58. SX, well, that's a calculator's version of S. That's our sample standard deviation, which you said was 1.2. N, we said was 15. The symbol off of H1, this is a less than. Well, symbol is less than, so if it's not already highlighted, we want to write her over, put our flashing cursor on less than, and press enter. Then down arrow to calculate, and press enter. Now our p-value is the p equals, so 0.0030. Okay, if p-value is less than alpha, well, alpha is 5%, this is less than alpha, so that's true. It says reject H naught. So for conclusion, we're going to reject H naught. Now H naught and H1s are opposites of each other, so if we reject H naught, that means we'll accept H1. Now our claim matches H1, so whatever we say about H1 is what we say about our claim. So we accepted H1, which means we'll accept our claim. Well, let's talk a little bit more about the word accept. That's not exactly true. Most books use the word do not reject. And as an example of that, I had a student one semester, art major. She got 7 or 8% on every test in college algebra, and throughout the entire semester. And to get 7 or 8% of my tests, you have to really leave a lot blank or not know what you're doing. Well, the final exam time came. She came in for the final exam, and she aced it. Got 25 out of 25. I know she cheated. She brought in the answers on her calculator or something. Her math skills were such there's no way she could get 25 out of 25 on a comprehensive final exam. So I don't accept her innocence. Accept is a pretty strong word. Basically, I do not reject her innocence. Because it's possible. Maybe she studied every second for the last 3 weeks. And maybe she just got lucky. Guessed on all of them and got them all right. You know, all those things are possible. Not likely, but very possible. Or not very possible, but possible. So again, do not reject is a more appropriate word instead of accept. But students seem to click better if I use reject and accept. So that's what I'll be using. Okay, let's look at our next problem. Mean amount of fluid in the bottom of a lens cleaner is 59. So telling us mu is 59 again. Researcher believes that the mean is different than that. Sounds like our claim. Different than 59. 35 bottles are sampled, so that's our N. So N is 35. And the mean is found to be 63. So X bar is 63. With a standard deviation of 2.3. So S is 2.3. These are sample values, X bar and S, because they're referring to the 35. Test a claim based on this information that alpha is equal to 1%. Okay. Let's go through our steps. Step 1. Write down a shortened version of the claim. We got that. These are mu's. Okay. Step 2. Come up with a null and alternate hypothesis. H naught always has the equals part on it. H naught is our null and H1 is our alternate. Now this symbol up here, different than, is a not equal to. And if we remember where we can put that at, we can put it on H1 only. So that's where that goes. And then these are opposites of each other, so if this is not equal to, this is equal to. like that. Step 3, see which one matches. Well, there's a not equal to. Here's a not equal to, so it matches H1. And step 4, find our p-value. This is t-test. So I'm going to press stat, right arrow to test, down arrow to t-test, press enter. We're given summary statistics again. Yours should already be select from before. Mine is too. So if it isn't, right arrow over and press enter on stats. Well, down arrow to mu naught. This is the number off of H naught, H1 claim, which is 59. And enter. Then X bar we said was 63. S is 2.3. N is 35. What did I do? Ignore what I just did. I don't know what I did. 2.3. Okay, N is 35. Symbol on H1 is not equal to, so our flashing cursor is already on not equal to. I'll go ahead and press enter on it and select it. Down arrow to calculate and press enter. Now the p equals is our test statistic. So we got 5.6 e to the negative 12. What that means, that e to the negative 12, that's scientific notation. That means move your decimal point 12 places to the left. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 5, 6. It's our p-value. Okay. If p-value is less than alpha, well, this is obviously less than alpha. It's a pretty small number. It says we reject H naught. So we're rejecting H naught. These are a conclusion. If we reject H naught, that means we accept H1. They're opposites of each other. Now our claim matches H1. So whatever we say about H1 is what we say about our claim. We accepted H1, which means we'll accept our claim. And when you look at it, it was 59 and it's changed. It's now 63. That's quite a bit of a change. I mean, granted, you have to take your standard deviation into account on that. But our alpha is pretty small too, 1%. So let's take a look at our third example. Let me grab a drink here. Okay, the mean amount of fluid in a bottle pop is 16.9. Researcher believes that the mean is more than that. Sounds like a claim. More than 16.9. 10 bottles are sampled. That's our N. And results in the following data. Test the claim based on this information that alpha is equal to 10%. Okay. Write down a shortened version of the claim. We did that. Come up with our null and alternate hypothesis. More than implies a greater than symbol. And these are mu's. Now greater than goes here, and this has to be less than or equal to. These are opposites of each other. And that would be 16.9 and 16.9. Step 3, see which one it matches. This is a greater than, here's a greater than, so it matches H1. Then it says find a p-value, use t-test. Okay. If I go to stat and go to test, it's pretty well going to guide you what to do. If I choose t-test and press enter on it, we're given raw data in this problem. We're given raw data. So we want to choose data. If I left arrow over, put my flashing cursor on data and press enter, you'll see it changes and it tells us list L1. Well, that tells us we need to put our numbers in L1. So I'm going to exit out. I do second mode. And now I'm going to go to stat, go in, enter on edit. And I'll put my numbers in L1. Now actually these are the same numbers we want in there, but let me go ahead and do it anyway. 16 enter, 16.1 enter, just so you kind of see the flow. 17, 17.5, 17.2, 17, 17.5, 16.3, 16.7, and 18.7. Okay, let me double check everything. 18.7, 16.7, 16.3, 17.5, 17, 17.2, 17.5, 17, 16.1, and 16. Now I wanted to show that just in case you're not really comfortable with entering data. These same problems I'm working with the classical approach with the calculator, p-value approach with the calculator, classical approach by hand, and p-value approach by hand. That's why you see these in there already. Okay, I do second mode. Now let's go back to our t-test. So press stat, right arrow to test, and down arrow to t-test. Well, we already got data selected, so I'm going to down arrow to mu naught, which mu naught was 16.9. It's a number off of h naught, h1, or your claim. So 16.9, enter. L1's fine. Now if yours doesn't say L1, assuming you put your data in L1, do a second 1. So we do second 1 to put an L1 there. Enter. Frequency, this should say 1. If it doesn't say 1, then press your alpha button one time and then press the number 1. And then the symbol on H1 was a greater than. So I'm going to right arrow over to the greater than and press enter on it. Down arrow to calculate and press enter. And P equals is your P value. So P is equal to 0.3516. Okay, p-value is less than alpha. Well, it's not less than alpha. Alpha is 10%, and this is 35.16%. P-value is greater than alpha, and that's true. It says accept h naught. So our conclusion is we accept h naught, which means we reject h1 because they're opposites of each other. Now, whatever we say about h1 is what we say about our claim. So we rejected h1, which means we'll reject our claim. Okay. Now, this book uses just one test for t-test. Your textbook may be different. The key to it, with most textbooks, is whether sigma is given or not. If sigma is known, then for your p-value, you'd use z-test. If sigma is not known, then for your p-value, you would use t-test. Now z-test is in the same location as the t-test. It's just the one right above it. You can't miss it. So anyway, something to keep in mind if you're using a different book, and they have two sections. One where sigma is known and one where sigma is not known, or they separated somehow. Go ahead and save that. Okay. Hypothesis test for a population mean. population mean, p-value approach, TI-84, beta 01. Yeah, that looks good. And let me stop the recorders.